This is Gail Kovac for Gresham Barlow School District, Summer School, High School Credit Recovery, Data Reasoning and Learning Target number 12. I can determine if two variables are independent given a two-way table. So we're looking at categorical data, we're looking at two variables and comparing the two in a table. And we'd like to know if these variables are independent or not. So independence means that one variable does not influence the other. There is no connection between the two. They are two completely different things. Like, for example, favorite flavor of ice cream and whether or not you know how to swim. I would not expect those two things to be connected whatsoever. So those are likely to be independent variables. You could have things as well that would be independent, such as maybe for children, height versus age, because children very typically tend to get taller with age. I would expect those two things to not be independent, for them to actually be connected and one influences the other. So let's take a look at this problem. On the left, it says the following two-way table shows the variables of age and job status such that they are not independent. So these are two things that are connected. We want to explain what that means and why it makes sense. So let's take a look at this table. So age is one of the things we're looking at. And it looks like we've got two categories. We've got categories of under 65 years old and over 65 years old. And then we've got another variable here, which is your job status. One is if you are retired, and one is if you are not retired. So let's take a look here. It looks like for younger people that are under 65, there's a little bit of them who are retired, but most of them are not. There was only 100 of those people who were surveyed. And now let's look at the older group, the group that was 65 or older. Most of them are retired. There are a little bit of them that are not retired. There's way more of those humans that were surveyed for a total of 400 people. So it makes sense that those things are connected, because usually people work for a long time of their lives, and then towards the end, that's when they have saved up enough money to be able to retire and no longer work. There are very, very few younger people that have already made so much money that they don't need to work anymore. So it makes sense that those two things are not independent, that they are actually connected. So these things are not independent, and that makes sense. Because younger people I'm going to say something like are less likely to be retired than older people, are less likely. And you would think after all these videos of me writing things out with my mouse that I would be better at it by now, but I am not. To be retired. Older people. And that's because they're usually still working, right? I'm going to do the B/C because they are usually still working. Still working. So that's why it makes sense that these things are not independent. And in the next problem, we would like to know, well, if these two variables were independent, what would the values of the table have to be? So if we were to redistribute this so that it was completely proportional and there was no connection between age and job status, then what should those numbers have to be? So we're still given the same totals. Let's still say that we survey 300 people that are older than 65 and 100 people that are under. Let's say still that we have 280 people who said they are retired and 120 who said they're not, but we want to redistribute them so we get equal proportions. So all I need to do here is figure out one of these 4 boxes, and then I can just use subtraction from the totals to figure out what the other ones have to be. So there's only one level of play here. So I want everything to be proportional to the totals. So I don't want to just put 50, 50, 50, and 50, because although that adds up to 100, that's not going to add up for the under 65. It's not going to add up to 100 here, and those numbers are going to add up to the incorrect amounts for the totals. So it still needs to reflect and honor the current totals. So let's take a look at some of these, and here's a couple ways you could do it. I'm going to look at the column of the totals here. So I had 280 out of 400 people who said they are retired. So that's 280, and that's out of 400. So I wonder what proportion that is. What percent is that? If I use my calculator to do 280 divided by 400, I get 0.7, and that is 70%. So 70% of people, regardless of their age, need to be in the retired category. So I want this to also be 70%, and I also want this to be 70% from here to here. So what does this value right here have to be out of 100 this time to show me 70%? So I'm going to do 100. I'm going to now multiply that by 0.7 to find 70% of 100, and that's going to give me a total of 70. So this question mark here needs to be 70 people to keep things proportional. So that's where 70 belongs. I'm going to make that look not like a 2. I'm going to try that again. This needs to look like a 70. That's a much better 70. So I could also use the same method to figure out what 70% of 300 is if I would like to. Or at this point, I could just do some subtraction and say, well, 70 out of 280, this has to be 210 left. And I bet you 210 divided by 300, I bet you that's 0.7 as well. In fact, yes, it is. And from here, I can just subtract and say, well, 70 said retired, so 30 needs to say not retired. And then from 210 to 300, that's going to be 90 that has to say that they're 65 or older and not retired. So once you find out one of those, then you can kind of just subtract away from the totals to find the remainder. So that's one way you could do it, is from the totals from the side. You could also find the exact same numbers by finding the totals along the bottom as well. So for example, 100 out of 300 people say that they're under 65. So I need these totals to also be 100, reflect that 100 out of, sorry, let me go back, say 100 out of 400, sorry, 100 out of 400. So this also has to reflect 100 out of 400. This one also has to reflect 100 out of 400. So let's see if, let's do 100 out of 400, I already know that's 25%. That gets you 0.25 in your calculator, which is 25%. So I need all of the other proportions to also be 1/4 or 25%. So then I can take my total of 280 and I can multiply that by 0.25. And that's also going to get me 70. So there's a couple ways there you could get 70. It's up to you. All you have to do is focus in on one of those proportions out of the total and figure out one of those 4 empty boxes, and then you're going to get all of the other ones as well. And this is keeping everything proportional to show that things are not at, or that things actually are independent now. So if you look at the under 65 column, now most of them say retired. We know that that doesn't really make sense, but you know, if these two variables were not related, that's what the numbers would have to be. And over 65, most are retired. So everything now adds up correctly, but the proportions now reflect that age and job status are not actually linked together.